All right, so continuing on with this chapter 3, solving multi-step equations. It says use notes from 3.1. So just jumping back, whoops, these notes right here. I'll go ahead and clear that. This is what I'm referring to when I say use the notes. So again, we're just going to add a few more steps because we did a 2-step, which involved these last two, and now we're going to be doing stuff with distributing and combining like terms. I'll do another lesson when we have to clear the fractions, when they have scary fractions in there. So, but right now we're going to do part B and C of step 1, which involves simplifying each side of the equation. So we are going to be leading up to where we have variable terms on both sides of the equation, so we might have to simplify both sides. But right now, it's just one side. So here are a couple problems that I'm going to do because it's easier just to kind of walk through them. So you can see we have distributive property here. Here we just have multiple terms on one side, so we're going to have to be combining like terms. And again, going back once again, distribute, combine like terms if we have to. Okay, so on this we have 3x minus 4x equals, or plus 6 equals negative 2. So if you can see here, we're going to just focus on this right here. All right, so our first step would be to combine any like terms you see in here. So in here, I have 3 terms on this side. I have 1 term on this side. I have a 3x and a negative 4x. All right, so I'm going to combine those two to a 3 and a negative 4. So 3 plus a negative 4, that gives me negative 1. So that's going to be negative 1x. And then I'm bringing down my positive 6. So I still have 2 terms on that side. And that equals my negative 2 still. So I have 2 terms here, 1 term here. Now I can take this constant, because I have to get this x term by itself, and subtract 6 from both sides. So I'm getting this negative x by itself. So negative x, I can call it negative 1x, but it's the same. That equals negative 2 minus 6. Negative 2 minus 6 gives me negative 8. And then we talked about this in the previous lesson. Anytime I have a negative variable, I can just divide it by a negative 1, and it makes it a positive. But I have to divide this by a negative 1 as well, because whatever you do on one side, you have to do on the other side. So x equals, and we have negative 8 divided by negative 1 would be positive 8. That would be my answer. Again, combining like terms if you have to before we start the adding and subtracting, multiplying and dividing. All right, so over here, again now on the right side of the equation, I have 2 like terms. I have a 4m and a negative 2m. So before I do that, I'm going to combine the 4 and the negative 2. 4 plus a negative 2 would be 2m. Bring down the plus 1. And that equals our 7. All right, so now again, I'm focusing on this 2m. I have to get that by itself, so I need to get rid of this. Use inverse operations to get rid of that positive 1. Subtract 1 from both sides. Let me use different colors just so you can see my steps. So I know at the end it just looks like a jumbled mess, but if I use colors, then you'll be able to see how I got to that point. All right, so 7 minus 1 would be 6, equals 2m. And of course, 1 minus 1 is 0. That's why we got rid of it. Okay, so now I have a 2 times m, and I want to get that m to be a 1. So now I'm at the division. 2 times m, inverse operation of multiplication is dividing, so divide each side by 2. That cancels out to just give me my 1m. 1m equals 6 divided by 2, which would be 3. Use your calculators, again, if you are still unsure with some of those operations. Okay, so now we have a couple problems where we have distributive property. One with just straight distribute, and then one within. Now there's a couple ways we can do this. We could see this as one term because there's 2 terms in here, but I'm gonna teach you guys so that it looks like this at the end, because we already know what distributive property is. This was these box problems. So you know, if I have right here, I have my 3 on the outside, my k here, and my 8 here. So that would be 3k and 24. So 3k, a positive 24, and that is going to equal my 21. All right, so now I have what looks like a two-step problem. I need to get this 3k. I need to get that to be a 1k, but I have to get rid of this 24 from this side. So I'm going to use the inverse operation of that. I'm going to subtract 24 from both sides. Let's get rid of it. Because 24 minus 24 equals 0. I have to keep it balanced, so I have to do it over here. So 21 minus 24. Keep those calculators handy. Negative 3 equals, that's gone, 3k. Now I have the 3 times k equals negative 3. I want to make this a 1, so I'm going to divide it by 3. This equals k. Negative 3 divided by 3 equals negative 1. Negative 3 divided by 3 gives me my negative 1. All right, the other way I was talking about, if we don't distribute, there's a way of doing this. I probably shouldn't show it to you because it'll be confusing, but it will come up later when we are of ways of simplifying things. Since this 3 is being multiplied by this grouping, that grouping stays together. So really what I could do is divide this whole thing by 3 and this thing by 3. So these 3's cancel out, leaving me with k plus 8 equals 21 divided by 3 is 7. Then you subtract 8 from both sides, and k equals negative 1. So you still get the same answer. I would like to see the distributing part first, because like a problem like this, it gets confusing if you just divide that to break that up. When it's standalone distributed property, it's okay. It kind of works out. But when you do this, if you don't do every term by 3, not just the one on either side, including that 9, then it gets kind of confusing. So I'm going to go ahead and use this distributive property here. So I'm going to, off to the side, I'm just going to show my work for you guys. Some of you guys are getting good at this, so you know that what it's going to be right away. So negative 3x, negative 1, negative 3x, and then negative 3 times negative 1 would be a positive 3. So I'm going to rewrite this problem. I have my 15 equals, now on this side I have negative 3x, I have a positive 3, and then I have that positive 9 over here. All right, so now this was what we just distribute, and part of our notes, I'm going to go back one more time, is then after we distribute, we can combine like terms if we have any. So distribute, combine like terms. So you notice the like terms that I have over here, it kind of makes it a problem like this, right? So I have a positive 3 and I have a positive 9. So now I can rewrite this. 15 equals negative 3x, and then 3 and 9 is a positive 12. All right, now I'm at that two-step equation to use. So I could subtract 12 from both sides because I want to get this negative 3x by itself, that term. So minus 12. 15 minus 12 gives us 3. So 3 equals negative 3x. That's a 0, so that goes away. This was that. Now I have to get this x by itself, and we divide by that number to get it to equal 1, negative 3. I divide this by negative 3. So this divided by itself is 1, so I have my x, which is my unknown. 3 divided by negative 3 is going to be negative 1. So my answer to this one would be negative 1. Again, all we're doing is saying, hey, what number, if I plug in for this x, that I could subtract 1 from, then multiply by negative 3, then add 9, will give me 15. So again, if you type that in, this is a little overkill, so I'm sure some of you guys would probably just stop this video now, but let's have some fun. So if I have my decimals calculator, let's bring that up real quick, where I can show my steps in there. And I am going to type this problem in on this left side, but I'm going to put the negative 1 in for x. So let's see how that would look. Negative 3, parentheses, and then I'm going to put my negative 1 in there, so parentheses negative 1, minus 1, close off that parenthesis, and then plus 9, And we have our 15 right there. And there's our 15, so it worked. Yay, we did it right. All right, so again, this is using those other two steps, distribute, combine like terms. Then you're typically adding or subtracting terms to get them on one side of the equation. And then you multiply or divide as your final step.